Alrighty guys, I want to try some more absolute value graphing examples with you. So if you would turn to page 80, I'm doing this one in a little bit of a different way. So I wrote out a bunch of examples, and what I would suggest is that you maybe pause and write these down as well. Now there are these three and then those two. There are two more down here also. So again, if you kind of want to pause and write them down and then come back and we can do them together, I think that would be the best way to approach it. Alrighty. So hopefully you paused, you come back, and we're ready to do some examples together. So again, we were talking about our absolute value functions. Our basic function looks like a absolute value x minus h plus k, where a is like my slope. It's telling me if the graph is pointing up or down, if it's narrow or wide. So like narrow if I'm bigger than 1, or like skinny. And then wide if a is like fractional between 0 and 1. So then it would be wide or going slow. And then h comma k is my vertex, where h is always opposite and the x value, and k is always the same and the y value, and like h is inside being added or subtracted, k is outside being added or subtracted, and there we go. So one type of question that we might want to figure out is, where's the vertex? The vertex is that key point of our V graph, because it kind of tells me where it's all centrally located, and then I can do my slope from there. So in this one here, my vertex is at h comma k, where h is the inside number being added or subtracted, but opposite, so 1. And then k is the outside number being added or subtracted, and it stays the same. So my vertex is 1 comma 3. Looking at this one here, if I want to find the vertex, I look inside to find the number with x, and there isn't anybody in there, so that's 0. And then I look at the number outside being added or subtracted, so that's 4. The 2 is like my slope. That number is being multiplied, so that's like my slope. That's how I should travel going from the vertex, like how fast or how slow. And then lastly here, if I want to find the vertex, I look inside with x, and that number is going to be opposite, so -5. And then I look for a number outside, and there isn't one being added or subtracted, so 0. And there you go. Now, down here, what I want to do is, based on the graphs, we want to write our equation. So I know that my equation should always look like A, absolute value of x minus h plus k, but I want to fill in A, h, and k. Okay, so like we were just talking about with the last ones, my vertex right here is kind of that key point. That's where I always like to start. And your vertex is like the point of the V. It's like the lead duck. It's where your two lines meet. And so I can see that the vertex right here is at -3 comma 2. So when I put that in, I'm going to have x minus -3. So it's going to change to plus. And again, it's doing that opposite thing like we were just talking about up here. And then outside, I'm going to put +2. The outside one stays the same. Now, the a value, I need to count and figure out my slope. So when I look at this point compared to this one, it's 1 away in the x direction, and it's 1 away in the y direction. So my slope here is just 1. So you can put the 1 in front or not. I usually don't, because I get it confused with the absolute value. Now, one thing that I do actually want to show you guys is, like, that is a crude drawing because it's not like on grid paper. So like if I go to Desmos really quickly and I type in, actually let me type it in over here so you can't see. Sorry. Like a graph like this. Now with that one, it's not going to necessarily put the point on there for you. So you got to look for that V, And I can see that right here, it's at 1, 0. So I would put like inside the parentheses or inside the absolute value, x minus 1, and then plus 0 on the outside, or just not put anything. And then if I want to find the a value, find the slope, I like to find another really nice crosshair point. So like as I go along the v, I'm looking for it to go right through the crosshairs. Oop, there's one. But this one's kind of nice right here, right there. So if I count like rise, run, like we were doing last chapter, from this point to this nice crosshair point right here, I have to go up 1 and then over 1, 2, 3, 4. So up 1 over 4 is the slope of 4, and now you can see that that is exactly what my equation was, 1/4 in the front, and then 1, 0. So just so that you can kind of see it on a graph. Now again, going back to mine, this bad drawing here without any grid lines, if I want to write my function for this, I'm going to do a absolute value of x minus h plus k, and I'm going to fill in a, h, and k with numbers. I always like to start with that key point, that vertex point, which again they're showing me is at 4, -2. So I'll have x minus 4. So it does kind of look like -4, but it's always opposite. And then on the outside, -2, because it's a -2. And the reason I'm showing you this other point is so that we can find slope. And so I notice that the x's are 1 away and the y's are 2 away. Now the thing to keep in mind is that when I'm finding slope, slope is always rise over run or y over x. So again, because the x's were 1 away, the 1 goes on the bottom. And because the y's are 2 away, the 2 goes on top. And so your slope is 2. Although, kind of -2. And negative because my arrows are pointing down. So this graph is going down, so it's negative. So -2. Alrighty. Last but not least, I wanted to try some graphs with you. So looking at this first one here, again, it's not going to be great because I don't have the graph paper in here for you. But the way I always like to start when I'm graphing is I like to find that vertex. So for this one, there's nothing inside and nothing outside. So I'm going to start right at 0, 0. Then I do the slope, which is my a value. So in this case, my slope is 1/3. So from here, I would go up 1 over 3. So maybe we'll just like kind of draw some little dashes in here. So like 1, 2, and then. So from my vertex, I need to go up 1 over 3. And that's the v going in this direction, but I also need to do it in the other direction. So up 1 over 3. So this is a real wide v. And I can tell that it was going to be wider because 1/3 is between 0 and 1. All right, on to this next one here. Again, I'll get a little graph going. And so first I think about my vertex. My vertex is the number inside, comma the number outside. So -1, comma -3. And so I go plot that key point at -1, comma -3. Boop, boop, boop. That's like where the point of my v is going to be. And so then I want to find my slope, which is -1/2. And so from here, I'm going to want to do down 1 over 2. So I guess I need a couple more little grid lines. So down 1 over 2. And you get your v going this way. And then down 1 over 2. And we get our v going that way. And again, because my a value, I know it's negative. The negative really just means that I'm pointing down. So it flips. Because the slope is half, that makes it wider again because half is between 0 and 1. It doesn't have to do with the fact that it's less than 0. So right here, when I was narrower, it's because I was 2. But it's also pointing down, so that's why it's -2. So hopefully that kind of makes sense. And yeah, I'm going to do one more video about absolute value graphs, but it'll be a separate one from this. There we go.